This is Mrs. Halley, and today we're going to be looking at 8th grade lesson 2.2, Properties of Integer Exponents. And our goal for today is I can apply the properties of integer exponents. So we're just going to jump right in with a reminder. Remember that when we're dealing with powers or exponents, the larger number is called the base and the smaller one is your exponent or your power. So we're going to start with multiplication. When two exponents have the same base and are being multiplied, what you can do is add their powers. Now this only happens if they have the same base. So if that bottom number is the same, or bottom exponent variable sometimes is the same, what we do is just add their exponents. And I'm going to show you why this works. So we've got 2 to the 5th power times 2 to the 3rd power. Now 2 to the 5th power is 2 times 2 times 2 times 2 times 2. And we multiply the 2 5 times. 2 to the 3rd power is 2 3 times. So here I've got it written out. If you look at this, this is 1, 2, 3, 4, 5, 6, 7, 8. It's being multiplied 8 times, so that's the same as 2 to the 8th power. So this is why it works. And it only works if this has the same base. If this were like 3 to the 2nd power, oops, that wouldn't work, because 3 to the 2nd power, we would have 2 times 2 times 2 times 2 times 2, and then 3 times 3. That's not the same thing. They have to be the same base because it has to be the same number that's being multiplied. So here's our second example. We have x to the 5th times x to the 20th. So they have the same base, x. All I have to do is add my exponents, add my powers. So 5 plus 20 is 25. So this comes out to be x to the 25th power. And again, this only works if the base is the same. Now, the second property that we're looking at is if two exponents have the same base and they're being divided. What you do is you subtract their powers. And again, I'm going to show you why. So I worked it out. So let's say we've got 4 to the 9th divided by 4 to the 5th. Now, 4 to the 9th, that's the same as 4 times 4 times 4 times 4 times 4. There's 9 of them there. Just trust me. 4 to the 5th, that's 4 times 4 times 4 times 4 times 4. There's 5 of them. Now, if you remember, whenever we divide 4 divided by 4, that is equal to 1. And the way we deal with that is we just cancel them out. So cancel out a top 4, cancel out a bottom 4, cancel out a top, cancel out a bottom. I keep having to go back and select my line selector tool, which is why this is taking so long. Cancel out the top, cancel out the bottom, and I'm going to do this 5 times. Top, bottom, top, bottom. So all of those 4s have canceled each other out, leaving just up here 4 times 4 times 4 times 4. On the bottom, all of these 4s, basically they've been divided to equal 1. So it's 4 times 4 times 4 times 4 over 1. Anything over 1 is the same as that number. So we get 4 to the 4th power. After I cancel out everything else, I'm just left with 4 4s. So that's 4 to the 4th power. So here's our next example. X to the 12th divided by x to the 20th. They have the same base. I'm going to do 12 minus 20. Now this is going to give me a negative exponent. X to the negative 8th power. Now x to the negative 8th power, that's the same as 1 over x to the 8th. Because remember, when we've got a negative exponent or a negative power, that's the same as 1 over whatever that was. We learned that in the 2.1 notes. Okay, here's our final property. When a power is raised to a power, you multiply the exponents. So again, I'm going to show you why this works. So we've got 7 to the 2nd power raised to the 3rd power. Basically what this means, I'm going to be taking 7 to the 2nd power and I'm going to multiply that by itself 3 times. So 7 to the 2nd times 7 to the 2nd times 7 to the 2nd. Okay, so that's 7 times 7 times 7 times 7 times 7 times 7. I end up with 7 to the 6th power. The easier way to get there is just to multiply 2 times 3 is 6. This is why it works. This is what it does. So again, look at my example. X to the 9th raised to the 5th. I do 9 times 5 is 45. And you can see I'm raising the power to a power. This is being raised on the outside. So we're going to be working over this over the next couple of days. We're going to be looking at why this works, how this works. We're going to do some practice. We will be going over this tomorrow. Bring any questions. Okay, bye.